What if the clearest evidence of an alien civilization isn't a signal at all? What if it's a shadow? A star that doesn't shine quite the way it should. In 1960, a physicist proposed that any truly advanced civilization would eventually need to capture the entire energy output of its star, and that if we looked closely enough we might actually be able to see it happening. This is the search for a Dyson sphere, and in 2015, astronomers found a star that made them wonder if they finally had. In 1960, physicist Freeman Dyson published a short paper with an unassuming title, Search for Artificial Stellar Sources of Infrared Radiation. His question was simple, but the implications were enormous. If an advanced alien civilization existed, but didn't want to communicate, how would we ever find them? Space.com. Dyson's answer, don't listen for a message, look for a shadow. Dyson reasoned that radio communication only works if aliens are willing to talk, but energy use is unavoidable. Space.com. Any civilization advancing technologically will need more and more power. Eventually, Dyson argued, a sufficiently advanced species would need more energy than their home planet could ever generate. The only place left to get that much power is the star itself. Dyson proposed that such a civilization might eventually construct a massive structure around its star, Arc-Civ, capturing a significant fraction of its total energy output, using material from planets and moons in its own solar system as raw material. And crucially, this structure would absorb starlight and re-emit that energy as infrared heat, which means it would be detectable, not through radio signals, but simply by looking for stars that give off far more infrared radiation than they should. Arc-Civ. If Dyson was right, somewhere out there, hiding in plain sight in ordinary telescope data, there might already be a star behaving exactly the way his theory predicted. When most people hear Dyson sphere, they picture something specific. A solid, unbroken shell completely enclosing a star, like a hollow ball with the sun trapped inside. That image is everywhere in science fiction, and it's almost entirely wrong. Dyson himself clarified this in an exchange of letters published in Science shortly after his original paper. A solid shell or ring surrounding a star, he explained, is mechanically impossible. The gravitational and structural forces involved would tear a solid shell apart, and it wouldn't orbit stably around its star even if you somehow built it. Instead, Dyson envisioned something far stranger and far more physically plausible. A loose swarm of independent objects, all orbiting the star on their own separate paths, together capturing a large portion of its energy. Picture thousands or millions of individual solar collectors, panels, habitats, or structures, each orbiting independently, like an artificial ring of matter surrounding the star instead of a single solid object. The simplest version might start small, a ring of solar collectors orbiting at a fixed distance, sometimes called a Dyson ring. Over time, a truly advanced civilization could expand this into a complete swarm, encircling the star from every angle, capturing energy no matter where the collectors sit in their orbits. Why would anyone build this? Energy is the ultimate currency of any advanced civilization. More energy means more computing power, more industry, more capability to reshape entire worlds, or build things we can't yet imagine. Dyson calculated that within a few thousand years of entering an industrial stage of development, any sufficiently ambitious civilization should be expected to fully exploit the energy available from its home star. A few thousand years. On a cosmic timescale, that's almost nothing. Which raises the obvious question: if this is such a logical next step for any advancing civilization, shouldn't we be able to see it happening somewhere? So, how do you actually search for something like this? You don't point a telescope at the sky and look for a giant metal ball. You look for something far more subtle, a mismatch in the numbers. Every star radiates energy according to its size, age, and temperature. Astronomers know, with remarkable precision, roughly how much visible light and how much infrared radiation a normal star of a given type should produce. But if a star were surrounded by a Dyson swarm, countless structures absorbing its visible light and re-emitting that captured energy as heat, the star would show an unusual signature. Less visible light than expected for its size and type, but significantly more infrared radiation than a normal star should produce. That mismatch is the smoking gun scientists have been looking for. Not a signal, not a message, just a star that doesn't add up. This search connects to a broader framework in astrophysics called the Kardashev scale, proposed by astronomer Nikolai Kardashev in 1964, as a way to rank hypothetical civilizations by how much energy they're able to harness. A Type 1 civilization can use all the energy available on its home planet. A Type 2 civilization can harness the total energy output of its entire star, essentially a civilization capable of building something like a Dyson swarm. A Type 3 civilization operates on a galactic scale, harnessing energy from billions of stars at once. For reference, humanity today doesn't even fully qualify as Type 1. We're still working our way there. A Dyson swarm would be the calling card of a true Type 2 civilization, a species potentially thousands or millions of years more advanced than us. Which is exactly why, when astronomers started scanning infrared data from thousands of stars, searching for exactly this kind of anomaly, most expected to find nothing. And then, in 2015, one star didn't behave the way it was supposed to. In 2015, a team of astronomers and citizen scientists working with NASA's Kepler Space Telescope noticed something strange in the data of a star called KIC 8462852. Now better known as Boyajian's star, or Tabby's star, named after astronomer Tabitha Boyajian, who led the study. The star was dimming, not in the small, predictable way you'd expect from a planet passing in front of it. Kepler recorded dips in brightness of up to 22%, far too large and irregular to be explained by any known planet. On top of that, longer-term observations revealed the star had been slowly fading for over a century. A separate and even stranger trend layered on top of the sudden dips. Astronomers proposed a range of explanations: swarms of comets breaking apart, unusual interstellar dust, a planet the star may have swallowed, causing instability, and one more explanation, more speculative than the rest, but impossible to fully dismiss. What if something artificial was orbiting the star? What if, for the first time, astronomers were looking directly at a Dyson swarm? For a brief window, this wasn't just internet speculation. Legitimate astronomers, including researchers connected to SETI, treated the megastructure hypothesis as worth actually investigating, precisely because nothing else fully explained the data. Then, in 2017, a more detailed study using NASA's Spitzer and Swift space telescopes, along with a ground-based observatory in Belgium, found the answer. The dimming was weaker in infrared light than in ultraviolet light. And that detail mattered enormously, because any solid object large enough to cause this much dimming, whether a megastructure or a planet fragment, would block all wavelengths of light equally. Dust doesn't behave that way. Fine, uneven clouds of dust block shorter wavelengths of light more than longer ones. And that's exactly the pattern astronomers found. The conclusion: Boyajian's star is almost certainly surrounded by an uneven cloud of ordinary dust, not an alien megastructure. It wasn't aliens, but for 2 years, one of the strangest stars ever observed became the closest thing modern astronomy has had to a real, actively investigated Dyson sphere candidate. treated seriously, tested rigorously, and only ruled out once the data left no other explanation standing. Boyajian's star turned out to be dust, but the search it triggered revealed something important. We now have the tools to actually look. Astronomers have scanned hundreds of thousands of stars for exactly this kind of infrared mismatch, the telltale sign of a civilization capturing the full output of its sun. So far, across every star we've examined, we've found exactly 0 confirmed Dyson spheres, which brings us back to everything this series has been circling since the very first video. If Type 2 civilizations are even possible, if the physics genuinely allows for a species to grow this powerful, then the absence of any confirmed sighting is its own kind of evidence. Maybe it means truly advanced civilizations are exceptionally rare. Maybe the Great Filter is real, and almost nothing survives long enough to reach this level of energy consumption. Maybe it means the dark forest theory is right, and any civilization capable of building something this vast has learned, long ago, to disguise or conceal it, rather than leave an obvious signature in the sky. Or maybe it means we simply haven't looked closely enough yet. That, somewhere among the hundreds of billions of stars in this galaxy alone, a Type 2 civilization is out there right now, quietly capturing the full power of its sun, and we just haven't pointed a telescope at the right one. Every star you can see with the naked eye has already been checked, at least loosely, for this exact signature. None of them have qualified, not yet. Until next time, stay curious, stay quiet, and keep listening. This has been Signal Lost. But megastructures and hidden signals aren't the only mysteries written into the sky. Sometimes the clue isn't something we're looking for. It's something ancient civilizations already claim to have seen. Next time, we're examining one of the strangest unsolved mysteries in astronomy, a star that vanished from the historical record entirely, and the search to figure out what happened to it.